Okay, so I have decided to record videos for those little programs that I do, and because on GitHub I upload them to GitHub and just no one's there, just nothing, just complete silence, and I decided to do these videos to, I don't know, someone might learn something from it, so that'll make me happy. Even if one person learns one thing, happiest person alive right here. So, however, I'm so sorry about the last video about the noise and stuff. Currently I don't have much good recording stuff to record these videos. So, and there was some construction going on the whole time. Just this place is just a mess. So, whatever. Okay. So this is literally the 10th time I'm recording this because every time something happens. So, whatever. What's the problem? What's this? It's a program that I compiled because most of it is just copy pasted from somewhere else to keep my system's time manually. Connect to an NTP server, get the time, set it to system time. That's it. That's all it does. Okay, so why would we need to do that? Isn't there any better way to do that instead of just running an application in the background the whole time? Well, it was supposed to be. See, here I have the Windows internet time setting. Okay, okay, it works now. Okay, it works now too, but it's unreliable, I can promise you that, and it can go bonkers any second, and if you're especially owning a server that is working with sensitive servers that are sensitive about their time, that will be an issue. So I was actually working on Binance's API. It's a cryptocurrency exchange, and it was always telling me your time is 2 seconds behind, 2 seconds ahead, and this thing wouldn't just work. Okay, I go here, click update now manually, it works, but the time that it had to actually automatically do that, no sign. So I decided to write this program, and okay, why does that happen? Why can't the system by itself keep the time? Well, it actually can. Your BIOS always keeps the time, but it just passes on the time to your operating system whenever your operating system boots. As if I can remember correctly, that's how it works. And from that point on, your operating system will try to keep the time by itself using the internet time setting. So a question might pop up in your head: why can't Windows just, without any internet and any kind of that stuff, just keep the time by itself? Does it have the quartz thing in it? Yeah, well, it does, but there's a thing. There's a thing called system interrupts. Well, basically means whenever you launch an application, you close an application, something crashes, something happens, your CPU kind of blinks, okay? And it doesn't know how many milliseconds its eyes were closed, okay? So it has to assume that. So if it assumes it wrong by even a millisecond, when you're running your system for months and tens of thousands of those system interrupts happen, it adds up to a, I don't know, 40 seconds of I don't know, time difference between the actual time and your system's time, and that's real bad, especially when you're running a server. So if you're on a home server, like, worst case scenario, you will be late to your important life-changing meeting just by 1 minute. Nothing specifically will happen. So But on the server side, it makes a difference because most of the applications, server applications, like work like that. You have to, like for example, the Binance thing that I was working on was actually it needed your time and your endpoint and encoded your whole request with those two parameters and then send it to the server. And if it was wrong, it wouldn't just respond. So here is the application, what it is. So, well, basically, it's an NTP client which connects to the server, takes the time, it sets your system time to the time that it got. So, how does it do that? Well, pretty basic stuff. You have your NTP server here, which, by the way, there's nothing wrong with Windows's NTP servers. They're just running perfectly fine. There's something wrong with their clients that can't keep the time. Like, I don't know why that happens. I've experienced this through many things, like my own personal computer, my laptop, my servers. Happens everywhere, and each of one of those has different versions of Windows, and some of them are getting updated and some of them not. But like, I mean, Windows, some are getting Windows updated, some not. Doesn't, I don't know, make a difference, I guess. I don't know what's from. And however, we have our NTP server here, time.windows.com, and NTP. What's NTP? A little bit more about that. It's basically an atomic timekeeping device that is connected to internet and gets requests and sends out responses, which contains precise time, universal time. Okay, so for us to be able to communicate with that, we would need to create a byte array of 48 because that's the standard, RCF 230. Okay. Always, anyway, your packet has to be 48 bytes long, but we don't. We're not doing anything really with 74 of them. So here we're taking the first slot of our newly initialized byte array, and we're setting the first slot to 27. Which can also be 0x1 capital B, which means the same thing. And there's some data sheet that I'll post below that you can actually read what those things mean. And we're basically, by sending out this 27, we are telling the server that we don't need any leap year leap indicators, and our version number is 3. Okay, we're sending out 3 because when the server's version is number 3, it's okay. When it's 4, it's backwards compatible, so it can respond to us. And the mode number 3 is the client mode, which has like broadcast mode, server mode. You don't have anything to do with those. You can just always set 27 or 0x1 capital B to the first slot of your array and just send it out. Okay, so okay, we initialized our array, we put in the data. So then we need to get the IP address of time.windows.com. Okay, so we do that through dns.gest get host entry and the NTP server address, which is time.windows.com, and then we get the address list. Okay, usually it has just one address, so anyway, whatever it is, we just want the first one to be sure that there's something, and the port of the port that NTP works on is 123, so that's good, and we make an endpoint out of it and keep it in IP endpoint variable. We have to communicate with the NTP server through a UDP socket, okay, which is basically a way of communication if you don't know about that. And in C# Well, almost everywhere, you first have to try to connect. You try to connect to the server. You have a timeout, okay? If this timeout is reached, like it's 3,000 milliseconds, means 3 seconds. If it didn't get any data in 3 seconds, we'll just give up and go with its own life. And then we send this that we initialized here, and then try to receive the response of the NTP server. And then we finally close the socket connection so we don't actually overflow, stack overflow. Okay, here's some technical stuff here. This server reply time actually means where the data that we want, what's the index of the data that we want, where's the beginning of the data that we want. And it's 40 bytes in, okay? So we have two parts here, the seconds part and second fraction parts, okay? So first we get this, okay? It's a unsigned integer, which is 4 bytes, and we get this, okay? This is the index, which are just passing 40 and get 40 from this for line of 4, and that's it, okay? The fraction part is the same as the server reply time plus 4, so there's 4 there. After that, we need to change the server's response that we send it to us from big endian to little endian, so we can actually work with it. Then we take the second part, multiply 1,000, same with the thing, and then add all of them together. I don't actually know what this is because, as I said before, or I didn't say before, this is not my code. This has been the standard way of communicating with NTP servers in C# for the last, I don't know, 8 years, like from 2014 or something like that, and even way before that. It's the same block of code. It's all around the internet, and yeah, I'll post the actual code's link down in the description, so if you want to check it out. Okay, then we have to calculate the data that we got. What does it mean? So here's some explanation. The NTP standard is that it's actually counting milliseconds from January 1st of year 1900. Okay, it's saying it's been this many milliseconds from January 1st of 1900. So first thing we do, we initialize a new date time. Okay, we said it's the year 1900, 1st of January, like 000 as our time, because we don't know what time it is, and we say it's UTC, so it has it all good. And then we say, okay, this is how many milliseconds I have. You get the milliseconds and give me back a formatted good old date time in UTC. So we get that here, and we return it to our main method, which is this. Okay, this is pretty basic too. I have a stopwatch here to calculate and take into consideration the milliseconds that it took us to send out the request, get back the response, and all that kind of stuff, and take that into consideration and minus that on top of the time that server gave us. So we have that, and plus we have to announce how behind or ahead we were from the actual time. So this is what this part does. Tick difference. So then we stop the stopwatch so it doesn't waste some resources. Okay, so actually, as Windows doesn't have any nice and shiny API of working with time and setting the time, we'll need to use kernel 32 DLL, which has a method called setSystemTime. And for that we'll need a struct, which is basically this, okay? And it's like basically a date time, but as in would that the kernel 32 would understand it. So we initialize our system time here. We fill in our data that we have, okay, and then we call set system time, and we reference the system time that we created here. And this is an external method. It goes from the DLL, runs this, and voila, magically your time is set to the system time that you gave to the method. That's it. And then I'm announcing that I have updated the time. It was this milliseconds behind or ahead, and then I'm sleeping for 10 seconds. So I updated every 10 seconds. So as you guys might remember from the beginning of the video that I was showing you the internet time setting thing, I updated my time, right? Okay. Let's run the program and see how many milliseconds is the difference of our system time and actual time. Well, you can run this. Look at this. 2,268 milliseconds. That's a lot. But however, I paused it here a bit, so, but not much. I was just paused it for 1 second, max 1.5. So even if it was 400 milliseconds, like it's been like 16 minutes since the beginning of this video, and I showed you in the first minute of the video that I updated the time. In 15 minutes, it had the time to make that 400 millisecond gap. So imagine that your server that is running for months, and that thing is happening there, and this is just 15 minutes and 400 millisecond of delay on behind or ahead, just the difference 400 milliseconds. That adds up when you're running the same session of Windows for months. So you don't want them, right? Okay, then let's go on. Let's see what will happen. Okay, so it paused us here. So I would like to go through the code and to see what actually happens. And okay, so here it's just we initialize our new packet, which is all empty now. We set 27 to its first slot, 27, sorry. And then our new, we get our host entry here, and it gave us one address, 52.166.120.77, and we made an endpoint out of it, and here it is. Okay, so socket connection. Here it goes, tries to connect, it connects and sends, receives, and then close, so we can avoid the good old Stack Overflow, which doesn't happen in C# because we have garbage collection here. So, but anyway, you don't want to be wasteful. And we had this before, so now we have to get our actual seconds part from the response that the server that gave us. Okay, so here it is, and here is the fraction part that we get from the actual. So we're using the same buffer kind of byte array here for sending and receiving, and that's efficient if it works. It works, believe me. And then we're here changing from the format from big endian to little endian. Okay, as you can see, it's 409 and ending 371. So now it's completely different. So we need to do that because everything will be just wrong. And we're calculating the milliseconds from these two, integer part and fraction part. and then initializing a new date time and adding the milliseconds, and there you have it. This is UTC time right now. But as we're debugging it, it takes a lot longer than it has to. So this time won't be precise at all. It won't be. It would be like, I don't know, 30-second behind. So okay, calculating the click difference, it was 34 seconds actually, and we stopped at stopwatch, initialize our system time, and no, don't set my system time, because we all know what will happen, and announce the time difference, and that's it. Okay, so usually the time difference is between 50 milliseconds between each iteration, so it's not that big of a deal. I don't want to spend more time on trying to minimize that 50 milliseconds, because that 50 milliseconds does no harm to anyone. So it's wasted hours on that to try to minimize that down to 0, because you can't, because you just have to assume everything in between the time that it took, that it gave us the response, the actual system interruptions that happened in between. It's the same problem, and you can't calculate how long exactly, precisely, in between the request going out and response coming back, because system interrupts happen there. A lot of difficult stuff. So this was my PTimeD walkthrough, and I'd like to do some live streams, and I don't know how I will start it. I'll do some C# adventure kind of stuff that I have some idea, but I don't know how to do it. I go around the web, find ways, and at the end we have a final product that I'll share with you guys on GitHub, and I'll experiment with the code, do whatever you want, even sell it if you can, and that's it really. I really hope you learned something from this, and thank you for watching. If you have any questions, suggestions, or anything, you just hate me, just let me know down in the comment, so I can communicate with you guys more clearly. And by the way, everything that I mentioned here, the links will be down in the description. So I guess that's it, not much. Once again, thank you for watching. You guys, see you in the next video.